Hey there, welcome back. So in the previous videos, so far we have looked at normal exponents. Then we also have looked at the negative exponents and also what the effect exponents may have on if you have a negative basis. But in this video, we're going to look at the third type of exponents that you can have that are the rational exponents. The rational exponents mean that exponents that are actual fractions. So just a quick recap that a to the power of n, that means a times a times a times a. That would be your n number of times. A to the power of a negative n, that means 1 over a to the power of n. But the third type that we need to look at is what if you have a to the power of a 1 over n? What does it mean then? At the same time, what if you have a to the power of m over n? What does that mean? Right? And that's what we're going to do in this video. The first thing we'll do is we'll look at rational, and they are something we call a rational exponent. We'll start off with the simple types, just to get the ball rolling. We'll begin with the definition. So I'll say to the power of a half, right? Now the actual definition of a rational exponential is that when every time you have a fraction being raised to a base, the numerator, that's this one, that it will be the power, and the denominator, that will be the root of the base. For example, we know that if you don't know already, but a root merely means that we finding two numbers, then when multiplied by themselves give you the answer that's within that root. For example, if I was to ask you to find the square root of 4, that means that I need two numbers, and with the square root means there's a number 2 there, that I want you to get me two numbers that when they are multiplied with themselves, they give me the number 4. And in that case, that would be 2, right? Because 2 times 2, that is 4. Let's say if I ask you to find me the cube root of 9. Now the number 3 here means that we need three numbers. When multiplied with themselves, they give you the number 9. And that would mean that's 3 times 3 times 3, or 3 squared, or 3 cubed is equal to 9. Now this and this is what we are going to look at. That is the connection. You already may have noticed that this is an exponent and that is a root. And that is how they are both fundamentally linked. Coming back to a rational exponent, now this can be rewritten as a with a square root. Did you notice something what we did here? So that means that the denominator of my exponent became the root, and this number, that is just the power, but more on that later. For now, every time if you have a base being raised to a fraction that says 1 over a number, then you can easily just rewrite that as that number, the root of this power, this denominator. Let's say if I had 1 over 3, then it just means a to the power of a 3. A to the power of a 4, then it just means a fourth root of a. A to the power of a 5 is going to be the fifth root of a. A raised to the power or of 1 over n, then the nth root of a. Now, coming to the next step, that what exactly does these roots mean? So keeping these examples in mind, that means that we need a number uh, when multiplied by itself twice needs to give you this number. So I need a number when multiplied with itself gives me a. Now I'm going to actually, there's not an equal sign, but more like a there. Multiplied by itself, that means b squared gives me a. So the answer to that root is actually b squared. Keeping this example in mind, the answer to this will be b cubed, b to the power of 4, b to the power of 5, b to the power of n, right? So, in other words, if I multiply b with itself n number of times, then I get the number a. Just like we saw here, right? If I had 4 and we tried to find the square root of 4, that means that we wanted two numbers that when they were multiplied with themselves, they gave us the number 4. And the number 4 was the number that was within this square root. The cube root of 9, that was that when we multiplied a number by itself 3 times, it gives us that number within that root. And that applies to any number. You can put that, and you can put any number into that fraction there. Like in this case, we put the number 4, but now we need a number that every time that is raised to the power of 4 gives me the number a. Because now we are using the language of the exponents. So in other terms, the answer to the cube root of a is a number when raised to the power of 3 gives me a. So that essentially is what these rational exponents mean. Let's take an example so that it's much more clearer to you on how it works. Let's say someone asked you to find u to the 1/3 of 27. Now this means that we need three numbers when multiplied with itself gives us 27. Now the best way to do it is that you start from 1. So 1 times 1 times 1, that gives us 1. 2 times 2 times 2, what does that give us? 2 times 2 is 4, 4 2s are 8. 3 times 3 times 3, that gives us 3 times 3 is 9, 9 3s are 27. Voila, that is our answer. So the answer is 3. The answer is what? The answer is 3. The answer is 3 because once that number is multiplied by itself three times, then you get the number 27. In other words, 3 cubed is equal to 27. And actually going back, I wrote the exponents as an example to explain to you on what it actually means, but the answer is not b cubed. The answer is just purely b, right? So for example, we know that in this example, 3 times 3 cubed is equal to 27. Therefore, the answer is 3 to the cube root. The base is the only answer to that one. Let's take another example. 4 to the power of a half. That would be the square root of 4. Now we need two numbers. When multiplied by themselves, they give me 4. And we know that 2, because 2 squared is equal to 4. Let's take a number, 256 to the power of a 4, to the power of 1, to the power of a quarter. That means that we do this, and then 256. So now we need a number, then when multiplied by itself 4 times, it gives us 256. And that, I can tell you, is 4. Because 4 to the power of 4, that is 256. So that is exactly what the the rational functions, rational exponentials mean when you are trying to solve these numbers. And I'm actually going to rewrite this right here, because b to the power of 3 gives you a, b to the power of 4 gives you a, b to the power of 5 then gives you a. And that's what we saw in the on the next slide just now, right? That 4, 2 give us the answer 2. 27, the cube root of 27 is 3, because 3 cubed is equal to 27. The fourth root of 256, that is 4, because if 4 is raised to the power of 4, then that would give you 256. So that is exactly, that is what these rational exponentials mean. Now going back, let's add that to our definition. So that means that it is the nth root of a. So if someone walks up to you and says a to the power of 1 over n, then you can just rewrite that as the nth root of a. But then moving on, let's take a more, because so far we have only looked at 1 over a number, right? Instead of that, let's take a look number where you have numbers on both sides of the fraction. So for example, a to the power of 2/3. What does that mean now? And maybe I should actually write here first that if something is being raised to the power of m divided by n, the denominator, that is your root, and this number is then your power or your exponent. What that means is that we write our cube or our root, which is 3. That means that the number at the denominator of number a, and then the numerator, it actually becomes our power. So that means that you are raising the you are finding the cube root of a, and then you need to raise it to the power of a 2. A, let's say we had 4 divided by 3, then again we will have 3, the cube root, and to the power of 4. Let's say it was the other way around, it was 3 over 4, then you would have to write a, but now you would have the fourth root to the power of a 3. So that essentially is how you would do when you are working with, when you're working with different when you're working with two different numbers. On the other hand side, now you may be wondering that what if you could also rewrite it as, instead of writing it like this, could you rewrite it as, if you could rewrite it as a to the power of 3. Now I'm of course just rewriting this cube and then take the fourth root of that number, right? Is the answer the same in both cases? Well, I don't know. Let's figure it out with an example. Let's take an example. 4 of 2/3. Okay, let us use the very first definition that we used, where we said that first I want you to take the cube root of 4, and then I want you to raise it to the power of a 2, right? Now, what is the cube root of 4? Now, of course, you can't really do that in your head. So to save us some time, I have done that in the calculator. So it is 1.59, and then we raise that to the power of a 2. And that gives you 2.51. Okay, that was easy enough. But then let's try to use the other definition, where we square the number first. So now we are doing the power first. We're putting the power to the brackets, and then I want you to take the cube root of that number instead. So first we'll do the power. That means that we are doing cube root of, which means 4 times 4 is 16. Now the cube root of 16 is actually also 2.51. There we go. So that means that both of these exponentials, they are exactly the same. So when you are trying to solve a rational exponent, it does not matter if you raise the base to the power first or you take the root first. The order does not matter. What matters is that what you do in its totality. So like you saw in the very first example, we did the root first and then we took it to the power and we got 2.51. On the second case, we did the square first and then we took the root and we still got this exact same answer. And it is actually one of the index laws. Algebraically, you can even prove it that they are the same. And the way to prove it is by saying that a to the power of m divided by n is actually the same as writing 1 over n to the power of m, or a to the power of m to the power of 1 over n. Because when you have these numbers in these brackets, then you're actually just multiply them together, right? So m times 1 over n is the same as 1 over n times by m. The order doesn't matter. So that means that you can either take the root first and then raise it to the power, just like we did in this case, or you can take the the power first and then take the root. Regardless, you get the exact same answer. But the main important thing for you to remember is that is this definition right here, that the numerator is your power and the denominator is your root. So going back, let us then simply add the definition right here. So if a is raised to the power of m divided by n, then it is a to the power of m to the power of 1 over n, or a to the power of 1 over n to the power of m. And now, of course, I hope you already know now that a to the power of 1 over n, that is the root that we're talking right above. So either way, you take the power first or the root, it doesn't matter. And so just a quick recap, if a base or a number is raised to a simple number to the number n, it means that you need to multiply that base with itself n number of times. If something is raised to a negative number, then it simply means that you need to rewrite that as a fraction, as 1 over that number, with that power. If something is raised to the power of 1 over n, then that means that you need to take the nth root of that number. If something is raised to the power of m divided by n, then the numerator is the power that you need to raise it to, and the denominator is the nth root that you need to take. And the order does not matter. You can take the power first and then take the root, or you can take the root first and then the power. That is all that you can do. And these are the 4 types of exponents that you will meet along the lines in different chapters in mathematics and in physics and chemistry, or in any other subject that the case may be. So once again, thank you so very much for watching. And if you did like the video, then do remember to like and subscribe to the channel for more videos. Thank you.